Hello students, welcome to MNC. This is my second lecture in dealing with some of the very important questions which may be coming for your JEE as well as Keam examination in the year 2020. The last lecture I deal with integration. In this session, I am dealing with some of the important questions in limits, continuity and differentiability. Okay. Here this is a question which is given in your display. The question is that you find the value of what? Limit h tends to 0, a plus h the whole square into sine of a plus h minus a square sine a the whole divided by h. This is a question on the session limits. Okay. Therefore you need to apply limit to this section, right? As you know that when you studied about limit, the basic idea of limit is that what? If limit x tends to a f of x is equal to what? We can directly substitute in the I can directly substitute in the position of x as a. That means limit x tends to a f of x is equal to f of a. That means in the place of x you can directly put the value x as a. Okay. This was the first thing you studied in limits, I think so. Yeah? Yes. That, for example, when you go to the question, see, limit x tends to 2, x square plus 1 divided by x plus 1 is equal to what? Here the limit x is tending to 2. That means, as per the rule, you can put what in the place of x, you can put as 2. That means you substitute in the value as 2 in the place of x. That means it is 2 square plus 1 by 2 plus 1. See here x is tending to 2. In the place of x, you can put the value of as 2. That means, what is that? In the place of x square is 2 square plus, what is it becomes 1, the whole divided by x plus 1. In the place of x, again you put as 2 plus 1. That means the answer is equal to, what is 2 square? What is 2 square? It is 4 plus, see what is here? It is 1 divided by 2 plus 1. The answer is what? 2 plus just to here what is happening? It is 2 2 plus 1, right? The answer is equal to 5 divided by 3. This is a way to do a problem in limits. Yes, but you know that it is one of the easiest questions, right? Whenever you do problems in limit, you have to understand that you have heard about the form 0 by 0 form, right? What is 0 by 0 form? It is known as indeterminate form. See, in this question, same way, when you put here limit, here h is tending to 0. That means in the place of h, you can put what? In the place of this h, I can put h as 0. In the place of this h, I can put h as 0. Right? Then you can write, what is that? It is a plus h the whole square. That means you are putting, in the place of h, you are putting 0. A plus 0 the whole square into sine of a plus 0. In the place of h, I put h as 0 equal to 0 minus a square sine a, see, the whole divided by 0. See, okay, what happened here? What is a plus 0? What is a plus 0? It is a. That means a square sine, what is that? A plus 0 is again 0 a, right? From a square sine a minus here again it is a square sine a, right? The whole divided by 0. Both are same, you cancel it. You get numerator as 0 and denominator is also 0. What happened then? What happened? You can see that it is of the form 0 by 0 form. In this section, see what is 0 by 0 form? It is known as indeterminate form, right? You heard about that? Indeterminate forms. What are the indeterminate forms? You heard about that? What are indeterminate forms? 0 by 0, infinity by infinity, infinity minus infinity. These are all which forms? You can name it as indeterminate form. Still we don't know the answers for this form. Yes? Okay. This is very important to be noted in limits problem. For what? Whenever the question is given in the limit, as limit, here the variable is tending to 0, you substitute the value. If you get 0 by 0 form, you have to do something in that question, right? You have to do something. Maybe there will be common term, there will be there, you take it common and cancel it, do like that. Okay, but the easiest way to do is that you can have you heard about this rule? It's known as L'Hospital rule. This is the most easiest way to do a problem which is based on limits. Okay, when we use this rule, L'Hospital rule, if we are substituting the value here, the limit is h here, h is tending to 0, you put the value, and if we get indeterminate form, go to this rule. Which rule? It is known as L'Hospital rule. See, as you know that when I had put the value of h as 0, and you get which form? The answer in this question, it is 0 by 0 form. You get 0 by 0 form. Therefore, you go to this rule. Which rule? The L'Hospital rule. What L'Hospital's rule says? Simple concept. In simple thing, it just, if a question is limit x tends to a f of x by g of x. If you put in the place of, you see, f of a divided by g of a, you directly, as you know, limit x is tending to a, in the place of x you put a. If you get 0 by 0 form, right, 0 by 0 form, you put what? You go through which rule? You go to L'Hospital rule. And what is this rule says? If it is 0 by 0 form, the L'Hospital rule tells that just you take, the limit is same, limit x tends to a itself, you take the derivative of the numerator as well as derivative of denominator. This is the rule tells. Okay, if again it is a 0 by 0 form, by substituting the value, that means if you substitute in the place of x, that means f dash a divided by g dash of a, that means in the place of x you put a, again it is a 0 by 0 form, again you get a 0 by 0 form. L'Hospital rule says again that you again take the derivative, that means limit x tends to a f double dash of x divided by g double dash of x. This is the rule tells. See, you take the derivative of the numerator and take the derivative of denominator separately. Don't forget that. Okay, going to the question. See, okay, in order to solve this question, as you see here, the limit h is tending to 0. In the place of h you put 0, and you get which form? 0 by 0 form. Then you go to which rule? L'Hospital rule. What is L'Hospital rule? Just you take the derivative of the numerator and take the derivative of denominator. That is which rule tells. Which rule? L'Hospital rule is telling, right? Yeah. Anyway, going to the question, completing the question, go. Yeah. You have to take what? You have to take the derivative of what? You have to take the derivative of what? Take the derivative of the numerator. To take the derivative of the numerator. With respect to what? Here the variable is h, right? Here the variable is h. See, the variable is h. That means with respect to h, you have to take the derivative of the numerator. That means limit h tends to 0. When you take the derivative of numerator, see, these are two functions. Which are two functions? Which are the two functions? This is one function. Which one? This one. The thing I am marking with what? With the blue ink. See, this is the first function. A plus h the whole square. And sine of a plus h is the second function. See, therefore you have to apply which rule? You have to apply product rule. What is the product rule tells? First into, that means first into derivative of second plus second into derivative of first. This is a product rule, right? Therefore you take the derivative of numerator. When you take the derivative of the numerator, here there are two functions which is in the form of multiplication. Therefore you go for which rule? Product rule. See, what is the first function? It is a plus h the whole square. First into, you have to take the derivative of the second. What is second? Sine of a plus h. When you take the derivative of sine, it is cos of a plus h, right? Into, you know what is the derivative of a plus h means? In the place of a it is 0 and h derivative it is 1. Doesn't need to write. Here it is, there will be 1 here, right? The first into derivative of second plus again second into, what is second? Second function is sine of a plus h. Second function a plus sine of a plus h. Then you have to take the derivative of the first one. What is the derivative of what? You take the derivative of which one? A plus h the whole square. You take the derivative of a plus h the whole square. How to take the derivative? As you know, you read it as x square. And what is the derivative of a plus h the whole square? 2 into a plus h, right? 2 into a plus h into, when you take the derivative of a plus h, the form a composite function, you already know that, right? 0 plus, it becomes 0 plus 1. Anyway, the answer is 2 of a plus h. Got it? Okay. Therefore, what happens here? Yeah, sine of a plus h into, you take the derivative a plus h, that, and what is the answer? 2 into, it will be a plus h. Understood? Right? You take the, you see, you take the derivative of what? You take, go to take the derivative of which one? First into derivative of this thing is written here, plus second sine of a plus h, sine of a plus h into derivative of a plus h the whole square is 2 into a plus h, right? Okay. Then going to what? Minus. I think you are taking the derivative of this many thing is taken. Yeah, you are taking the derivative of this thing. Minus, what is the next thing? Minus, what is the a square sine square? Since you are taking the derivative with respect to h, here no h is there. That means this thing is fully a constant. That means you can put 0. You can put 0. Getting it? Yeah. Okay. Good. The whole divided by what is here? The whole divided by what is in the numerator? What is there in the numerator? What is there in the numerator? You can see that. What is there? Here it is. Sorry. Here it is h. That means when you take the derivative of h, it is 1. See, you take the derivative of the numerator and you take the derivative of the denominator separately. Then you can, as per the rule, here the limit, here the h is tending to 0. In the place of h, you put h as 0. That means the answer is equal to a plus 0 the whole square cos of a plus 0, right? Plus sine of a plus 0, right? Again, 2 into, in the place of h, you put 0. Minus, what is here? It is also 0. See, the whole divided by, it is 1. Therefore, you doesn't need to take 1, right? Is it necessary? No. You take it, but the whole divided by 1. See? Okay. Are you getting it? Yes. Then what is the answer then? Going to the next step. What is the remaining? See? What is that? A plus 0. What is a plus 0? It is a plus 0 is a. That means it is a square. It is a square. Then what is that? Cos of a plus 0. What is cos of a plus 0? It is a itself. That means a plus 0 is a. Therefore it is cos a. A square cos a. Right? Again plus. Again, what is here? Sine of a plus 0. A plus 0 is a. That means sine a. Right? Here it is a plus 0. It is a. 2 into a. It is 2a. Therefore the answer here is a square cos a. A square cos a. Right? A square cos a plus 2a sine a. 2a sine a is the answer. Going to the options here. Is there an option here? See? A square cos a. Yeah, it is a square cos a is there, right? Then what is that? 2a sine a. 2a sine a is there. Therefore, they can tell the answer as a is the right answer. This is the right answer for that. See? This is a way to do a problem when we are applying limit to a function. See? Whenever there is a problem in limits, when you put the values in that question, if you get 0 by 0 form, go to which method, which rule? Go to which rule? L'Hospital. It will be very, very easy. You know, when you take the L'Hospital rule, what you are doing? Just you take the derivative of the numerator and derivative of denominator separately. Is it clear? Okay, good. Okay, going to the second question. Here is given here. If f of x is equal to cot inverse of x raised to x minus x raised to minus x the whole divided by 2, then f dash of 1 is equal to. You know that when you write f dash of something, it means you have to take the derivative of this function. Therefore, you have to take the derivative of which one? Cot inverse of this thing. Cot inverse of which one? X raised to x minus x raised to minus x, right? The whole divided by 2. You take the derivative of this thing. As you know that, what is the derivative of cot inverse x? What is the derivative of cot inverse x? What is the derivative of cot inverse x means? What is the derivative of cot inverse x means? The derivative is minus 1 by 1 plus x square. You have studied that, right? But see that in the place of x, what is there? Something very big, right? See, x raised to x into something very, very big. And if you in the place of x, when you substitute this thing and you go through, when you take the derivatives, goes on, you won't be able to get an answer for that. Okay. Whenever there is a function which is inverse trigonometric function is given to you to take the derivative, you know that how to do that. Whenever it is there, inverse functions coming, you write, you study that cot inverse of cot x is equal to x. You study this result, right? That means you have to make this function to simplest form. That means in the place of this thing, in the place of which one? In the place of x raised to x minus x raised to minus x the whole divided by 2, in the place of this thing, you have to make it in the terms of cot. Then only you can simplify that question. Okay. Then going to solve the question. See how to solve this question. Going to solve the question. See how to do that. See, what is the question given to you? What is the question here? F of x is equal to cot inverse of x raised to x minus x raised to x the minus x the whole divided by 2. Okay. That means, see, before going to derivative, you need to simplify this question. X raised to x minus x raised to minus x the whole divided by 2. You can write like that. And then going to the next step, what again at cot inverse of, this can be written as x raised to x minus, this x raised to minus x can be written as 1 by x raised to x, right? The whole divided by 2. Is it clear? Yes. Then what to do then? See, what to do then? You see, take the LCM, you know, it is divided by 1. So it becomes cot inverse of, what is happening? Here you multiply, 1 into, multiply these two things, the denominator is which one? It is x raised to x, you get x raised to x there. When you multiply here, x raised to x into x raised to x minus 1, right? The whole divided by 2. See. Okay. Right? Then what to do then? You know that? What is that? X raised to x into x raised to x. These two things. What will it become? Cot inverse of, what is that? X raised to x into x raised to x raised to x into x raised to x becomes x raised to which x? 2x, right? Therefore you can write x raised to 2x minus 1 by, this becomes 2 into x raised to x, right? This 2 comes here, right? Yeah. Then what to do then? Again go into section. Then the question here is, what is the question here? Cot inverse of, what is that? X raised to 2x minus 1 by 2x raised to x. See. Okay. See, what is my task? To make this thing, this thing in the terms of cot. Then only you can simplify this question. Okay. Then here I am substituting x raised to x as tan theta. I put x raised to x as tan theta. Then what happened here? Cot inverse of, what happens here? X raised to 2x. That means x raised to x is tan theta, then x raised to 2x means it is written as x raised to x the whole square, right? Right? X raised to 2x can be written as x raised to x the whole square, which is equal to, you can write it as what? You can write it as tan x the whole, tan theta, x raised to x is tan theta the whole square, which is equal to, you can write as tan square theta, right? Therefore you can write it as tan square theta. Okay. Then cot inverse of tan square theta minus 1 divided by 2 tan theta. See. Okay. You got it? Yes. Okay. Then what to do then? Here, then what is happening? You know that tan 2 theta is equal to, you study the result, what is that? 2 tan theta divided by, you study this result, right? Tan 2 theta is equal to 2 tan theta divided by what? It is 1 minus tan square theta, right? Therefore you can write cot 2 theta as what? 1 minus tan square theta divided by 2 tan theta. Taking the reciprocal, you can write tan 2 theta becomes cot 2 theta. See? Okay. Then what is here? See? Cot inverse of, see, what is that here? 1 minus tan square theta. I take minus as common. You can write as, here this is tan square theta, here this tan square theta minus 1. When you take minus as common, you can write 1 minus tan square theta by 2 tan theta. See what happened here? What happened here? Both of this is same, right? That means you can write this thin, this much thin as what? Cot 2 theta. That means, what is here? It is equal to cot inverse of what? Minus cos 2 theta. Minus, not cos, minus cot 2 theta. What is the answer then? When you studied inverse trigonometry, you have studied this result. What? Cot inverse of minus x is equal to, you write as pi minus cot inverse x. You have studied this result, right? You have studied it, right? Yes. Therefore, cot inverse of minus cot 2 theta, here it is minus, okay? It can be written as pi minus cot inverse of cot 2 theta. You can write, when you need to remove this minus. Which minus? Which minus? This thing. See this minus. Whenever there is a minus in cot inverse of minus x, when you have to remove minus, you can write it as pi minus. Same thing, same properties applied here. Cot inverse of minus cot 2 theta, you have to remove this minus. How to remove? You can write as pi minus cot inverse of, that minus is removed, cot inverse of cot 2 theta. See, cot inverse of cot. See, that function here, that big function. Which function? This one, this very big function is turned into the term of cot. That means you can write as pi minus cot inverse of cot 2 theta. You can write it as 2 theta. You can write it as 2 theta. That means here the f of x is equal to pi minus 2 into, what is theta? What is theta? What is theta? Where is the substitution? Yeah, here it is substitution. Here see, what is that? X square x is equal to tan theta. See, you have substituted x raised to x is equal to tan theta. Then what is theta then? Theta is equal to tan inverse of x raised to x. Theta is equal to tan inverse of x raised to x. Then, therefore, the function f of x is equal to pi minus 2 tan inverse what? X raised to x. This is the question. This is the function. That means you have simplified this big thing to as, how to write here? What is it? What you got? You simplified that f of x as, what f of x is equal to, what is that for f of x here? It is pi minus 2 tan inverse x raised to x. See, okay, this is the function. What is the question here? You have to find f dash of 1. That means f dash means you have to take the derivative. You have to take the derivative. See, here pi is a constant. The derivative constant is 0 minus 2 into. What is here? What is the remaining? You have to take the derivative of which one? 2 tan inverse x. You have to take the derivative of 2 tan inverse x, right? That means the constant is being taken outside. What is the derivative of tan inverse of x raised to x means? First of all, you have to know what is the derivative of tan inverse x. You know how to take the derivative, right? Yes. You studied that tan inverse x, the derivative of tan inverse x is 1 by 1 plus x square. Then, what is the derivative of tan inverse of x raised to x? What is that? It is what? 1 by 1 plus, here what in the place of x, what it is the x raised to x, right? X raised to x the whole square into, again you have to take the derivative of which one? You have to take the derivative of x raised to x. What is the derivative of x raised to x? By heart it, x raised to x into 1 plus log x. Since it is entrance questions, don't go, this is, you take the derivative of x raised to x in your textbook as you apply log on both sides and you have studied that. You by heart the result, what is the derivative of x raised to x? X raised to x into 1 plus log x. Therefore, when you take the derivative of tan inverse, x raised to x, what is answer? What is answer here? Sorry, what is answer here? X raised to x, it is equal to 1 by 1 plus x raised to x the whole square into you take the derivative x raised to x, that's the answer, x raised to x into what is that? 1 plus log x. This is a derivative. Okay, therefore you can write here as 2 into tan inverse x derivative 1 by 1 plus x raised to x the whole square, right? This is x raised to x the whole square. That means you can write it as x raised to which x? 2x into what is remaining here? Into what is remaining? X raised to x into 1 plus log x. This is a thing. See, this is f dash of x. What is the question? You have to find f dash of 1, right? You have to find f dash of 1. What is f dash of 1? F dash of 1 means in the place of x, you replace by 1, right? That means 0 minus 2 into 1 by 1 plus 1 square, right? 1 square into 1 raised to 1 plus 1 plus log 1. See, in the place of x, you put all 1. Therefore, the answer becomes 0 minus 2 into. See, this is x raised 1 raised to 2 raised to 1. That means 1 square itself. 1 square is 1. 1 plus 1, it is 2. That means 1 by 2 into 1 by 2 into again 1 raised to 1, it is 1. Again 1 plus in the place of what it is, what? Log 1, right? In log 1, it is 0. Yeah. That means the answer here is 0 minus 2 into 1 by 2. 2 get cancelled. The answer you get is minus 1. That means which option? Going to the option number A. Therefore, the answer of this question is option A is the right answer. You got it? Okay. See that you go through this question. It's a very important question. And see that whenever the functions, you take the derivative of a function of an inverse trigonometric functions, always see that you have to make this big function in the terms of that inverse given. If it's cot inverse, you have to make this thing to cot in terms of cot. If it is in the place of cot inverse, if it is tan inverse, you make this in the term of tan by using suitable identities and suitable substitution. Is it okay? Is it clear? Okay, good. Thank you.